Okay, this video is going to continue showing some of the answers to the IB Math Studies Specimen Paper 1, 2014. I'll have my calculator up over here on the side in case we need it. I've already done a video of 1 through 5, so we're going to start in on number 6 here. We have a three-dimensional trig question. We have the diagram. Everything that it says in the question is already labeled on the diagram, so we can jump right in. Calculate the length of AC. AC is going to be the diagonal of the base here, from vertex to vertex. And since it says the bottom is a rectangle, we know that the corners of that base must be right angles. So we have a right triangle, ACD, with 20 and 15 as the two legs. So 15 squared plus 20 squared equals AC squared. If we need the calculator to solve that one, we just do 15 squared plus 20 squared, and square root that answer. If you recognize that this is just going to be one of those perfect Pythagorean triples, you'll know that AC is going to come out to exactly 25. Units are centimeters on this. Second part asks us to find VC, and that's from the apex of the pyramid down to C. There's a few ways that we can do this. I will use this right triangle, right? VNC, I think this is going to be the best way. Knowing that there's a right angle there, knowing that VN is 30, and MC is half of the base set, or half of the diagonal that we just found. So since that's 25, then this must be 12 and a half, 12.5. And again, I can use Pythagorean theorem. So I'll be using 30 squared plus 12.5 squared equals VC squared. Go over my calculator. I'm going to do 30 squared. I'm going to add 12.5 squared. I'm going to take the square root of that answer. And it's 32.5 for VC. 32.5, and I put my units on it, just in case. Right, those were worth 2 points each. And then the second part is asking us to use some trig. We're going to find an angle between VC and the base. So the angle that's between VC and the base is going to be that angle right there. Now we can use the 30 that we just used and the 12.5 if we want to find that angle in the right triangle VNC. So we just have to decide if we're going to use sine, cosine, or tangent to find that angle. And because I have the 30 and I have the 12.5 and I'm fairly confident that 12.5 was correct, I can use tangent. So the tangent of the angle I'm trying to find, I'll call it theta because I don't know, is going to be opposite over adjacent. And then to solve for an angle when we don't know it, we're going to have to do the inverse tangent. So I'll take out my calculator, do the inverse tangent, 30 divided by 12.5. Your calculator is in the right mode, then you should be fine getting an answer here in degrees. So 30 divided by 12.5. Let's make sure that we get an answer that seems to make sense. And 67.4 degrees makes perfect sense. So there's the angle. Calculator was in the correct mode. So that's that. Here we have a little mathematical models question function. On the grid below, we're going to sketch the function. 2 times 1.6 to the x power. Sorry, this is so tiny. Let's see if I can make it just a little bigger. There we go. Okay. We are going to sketch that function only for the domain 0 to 3, and this is important. It tells us that we're only going to sketch it for 0 to 3. Including 0 and including 3. That means our starting point needs to be at x is 0, and our ending point needs to be at x is 3, and the graph shouldn't go beyond that, nor should it be shorter than that. Okay? So you might want to make a table for this. You might want to use the calculator to graph it. If you use the calculator to graph it, so we're going to go ahead and add a graph page. Just need to make sure you're pulling up the correct information, or enough information. So 2 multiplied by 1.6 to the power of x, and we graph it. Okay, it looks like this. Now I only want to see the part of this graph between 0 and 3, so I have a few ways I could do that. I could just change my window. This might be the easiest way. Making my x minimum 0 and my x maximum 3, and then I'm seeing exactly what I'm supposed to see. My y values aren't high enough. See how I go all the way to the end where x is 3 and the graph is off the top of the page? I'm going to have to change my y maximum so that I can see that ending point. So let's make the y maximum a little higher. There we go. Now I can see I've got a starting point, I've got an ending point, I need to get that onto this graph. If you want to figure out the starting point and the ending point, rather than using the calculator to do it, if you know that x is 0, you can just plug in 0 to the function for x. So 2 multiplied by 1.6 to the 0 power. Well, 1.6 to the 0 power is 1, and 2 times 1 is 2. So I know my starting point has to be here. And then I'm going to plug in the ending point, which is 3. So if I plug in 3, I'm going to have 2 times 1.6 to the 3rd power. You can take out a calculator page to do that. All right, so 2 multiplied by 1.6 to the 3rd power, 8.192. So somewhere up just a little bit above the 8, I'm going to go ahead and put my point when x is 3. All right, that looks right. And then I just need to connect these with a nice smooth curve, going back to my graph, that looks something like this. So I'm going to connect these with a nice smooth curve showing my exponential growth. That one didn't quite connect. Try that one more time. There we go. Okay, the points in between don't need to be precise. It says in the answer key to give full credit that the first point is correct, the ending point is correct, and the curve is a smooth curve. Okay? Then for part B, write down the coordinates of the y-intercept of this graph, right, of y equals f of x. They just have to write it that way because they're asking us for a y-intercept. The function was called f of x, so they have to define that y is f of x. We're going to find the y-intercept right there, and it's asking for it as coordinates. Couldn't be easier. It's right there on the graph. We plugged in 0 for x. We got 2 for the y. So 0, 2. Common mistake there is just to write it as 2, 0 by mistake. The x value is 0. The y value is 2. On the same grid, we're going to draw the graph of a new function, g of x. We'll do this one in red. That's a linear function. Also on the domain 0 to 3. So I need to make sure that my starting point and my ending point is correct for this as well. My starting point would be when I plug in, I'm not even going to take out a calculator to do this one. I'm going to plug in 0 for x. 5 minus 0 is 5, so that means my y-intercept is over here. My ending point will be when I plug in 3. So I plug in 3, 5 minus 2 times 3 is 5 minus 6, and that's negative 1. So my ending point needs to be right here. And then I would take out a ruler. I'm not going to take the time to get a ruler out, but we want this to be a straight line that goes from your y-intercept at 5 to the ending point at negative 1. That's supposed to be a straight line. Sorry, it looks a little curved. And then we would get our full credit there if we have the intercept in the right place. Oh, I guess I do need to fix it because the other intercept should be exactly located at 2.5, right here. We want to make sure that that point is correct as well in order to get the full credit for full marks for this question. So we really would want to take out a ruler and make sure that we're going through all 3 of these points, right? We need the correct intercepts, we need the correct endpoints, we need to have a nice straight line to get the full marks, okay? And then use your graphic display calculator to solve where does f of x equal g of x. Just make sure you know that when you're solving for the value of x, right? You're not supposed to be giving a coordinate for this. So we're solving for the value of x where the two functions are the same. So one way to use your calculator to do this, since I already have the graph up, would be to insert another equation to this graph. So I'll insert the linear equation, which is going to be 5 minus 2x. And then look for the place where these two things intersect. Oops, typed it wrong. Let's get that equation back. Typed it in, down to 5. Let's fix that. So 5 minus 2x. Graph it. We're going to look for the place where these two things intersect. The calculator will get it for you. Go to Menu, Analyze Graph here, Intersection Point. Click once on the left and once on the right. It calculates that the intersection point is 0.943 and then some y value that doesn't matter. We're supposed to only give the answer for x. X equals 0.943. A solution to an equation is the value of x. So when it says solve, only give x. You are not allowed to get any partial credit on that question if you gave the y value also, even if you had the x value correct. Here we have a statistics question, a chi-square test. Should be pretty quick. We're going to first find the expected number of female volleyball players under the hypothesis that gender is going to affect the sport you play here. Expected number of female volleyball players. So that would be the expected frequency for this box. To find our expected frequency, we're going to do the total from this column, so 20 plus 15 is 35, and the total from this row, which would be all the females, 20 plus 15 plus 15. Multiply those two, and divide them by the total on the entire table. So the total on the entire table is 50 females, 70 males, so 120 people on the table altogether. So we'll want to do 35 multiplied by 50 divided by the 120 people that are on the table altogether. Let's go to my calculator page that I was working on here and do this. 35 times 50, keeps missing my first stroke. 35 times 50 divided by 120. So the expected value for that part of the table there is 14.6. Yes, it's okay to have a decimal number of people. You need to give no fewer than 3 significant figures when it doesn't say. Okay, so expected frequency, and it doesn't need to have any units on it. The p-value for this test we're only going to be able to get from the calculator. So on whichever calculator you're using, you want to do a matrix. So I'm going to go ahead and add a matrix in here so that my calculator can help me find a p-value. I have 2 rows. I have 3 columns. I'll type in the data as it stands for the table right on the test. So 40, 20, 10, then 20, 15, 15. I'm going to store this matrix, call it A. I haven't used the variable A yet, so we'll go outside of the matrix. Store it as A. Okay, so now it's stored the matrix as A, so I can go to menu, I can go to statistics, and I'm going to be performing a chi-squared test, which will be under, not there, be under stat tests. All right, so chi-squared, two-way test. The observed matrix, I just called it A. It's going to calculate the whole expected matrix for us. That's going to give us a chi-squared value and a p-value, so you can see the p-value right there. So p-value for this test, we're just going to use 3 significant figures, 0.0746, knowing that that first 0 after the decimal is not significant. So if you rounded this to 0.075, that would not be sufficient. And then we're going to state with a reason the conclusion of this test. I calculated the p-value. I have the significance level. That's given right here. So that means I have to do the p-value and significance level comparison, not the chi-squared comparison. Chi-squared needs to be compared to a critical value, which is not given to us in the question. You can't get a critical value from your calculator. You can only get it from a table of critical values, and they don't show it to us here. So we have to use the p-value. When we write the comparison, we have 0.0746. This is a value that is greater than 5%, because 5% is written as 0.05. And when your p-value is greater than your significance level, that means there isn't a relationship between these two variables. There's not dependence. So because these two things are independent, we're going to say sport, gender. Actually, we should word this in the correct order. Sport is independent of. So we're saying which one is independent of the other. Of course, gender is independent of the sporting club, but sport is independent of gender is what was being tested here. Rather than saying anything about the null hypothesis, because it didn't ask us anywhere to state the null hypothesis, so at this point, it wouldn't be appropriate for us to accept null hypothesis that hasn't been stated anywhere. If you wanted to state the null hypothesis and say that you accept it all as part of your answer to C, you can. It's just a fairly long answer. So we can just say sport is independent of gender without ever having to define a null, say whether we're accepting or rejecting. This gets right to the heart of the matter. And let's see what the next question is, so I know whether we can fit it here in this video. Let's save this question for the next video. Okay, so that is all for this one.